This is John Black, Super Chemist, and this is part 3 of P2P Synthesis in 90 minutes. The only thing we got left is the inert atmosphere to talk about, and I also wanted to bring up it's illegal to make P2P in most places, so I don't condone making it. I'm just going over this reaction, that's all. Alright, so I want you to notice something about the reaction. These are ions, most likely. They're going to be soluble in the acetic acid, I assume, and they will be ions, I would guess. So that reaction has to take place in the clot. Can't be, the ions aren't going to be jumping up into the top of the flask where you're refluxing. So at least some of your reaction has to be contained to the liquid part. You know what I mean? So what's in the vapor part is really irrelevant, whether there's oxygen in there or not. Just on that aspect. I mean, this could always, the xenolate maybe could fly up there and touch some, atmosphere or this. Now this would be your apparatus, right? And you got, this would be a drying tube where you put some cotton in here, not plug it, just, put a little bit of cotton. Put your calcium chloride in there so no water can get down in there, right? Now look at this space. This is a 2,000 milliliter flask. You're going to have about a liter of volume for the vapor to be in, right? This is a constant 22.4 liters per mole. This is just, all this stuff here is just estimations. I'm not going into exact figures, okay? It doesn't matter exactly what I come out with at the end. Just listen to this. 22.4 liters, a mole will take up that much volume of gas, any gas, whether it's air or whatever. So if you think about that, you have a liter, right, here. So remember, it's 22.4 liters per mole. If I just flip that, since it's a ratio, right? A ratio is a ratio. It doesn't matter what order I put it in. So I put it in this order. So I divide. 1 divided about 22 point whatever, 4, and I get this. So there's 0.044643 moles of gas in 1 liter of volume. Okay, that's how much, an ideal gas. We're not getting in, actually it'd be a little bit more because we're heating it and blah, blah, blah. But we're not going to get exact, all right? Now I want you to think about this. Oxygen, well, I just made these numbers up. They're pretty close though, I'm sure. So don't crucify me if they're a little bit off. Oxygen is about 21% of the air. Carbon dioxide is about 0.04%. And water is about 4%, okay? And the rest is nitrogen and argon and, minute, traces of stuff. But these are the three that you mainly want to keep out of your reaction when you have an inert atmosphere. Now the water, I don't think it's that much of a concern because you're allowed to use the dihydrate. If you're allowed to use the dihydrate salt, the manganese triacetate, you're allowed to use the dihydrate of it, you're putting water in there anyways. So I don't think it's the water. How much I think it's the carbon dioxide. And the oxygen because of the double bonds. Because it has the 2 double bonds and it, 2 carbonyls on it. But let's just say it's the oxygen. Let's just say the biggest thing, let's just say 20% of the atmosphere might screw up our reaction. Okay? Now remember, we said in 1 liter of volume, you can only get this much moles into it. Now, like I said, I'm just guessing. I'm not making exact numbers here. But let's say half of the air in this, when you reflux it, right, this stuff is going to be most of the stuff that's in the atmosphere, in this empty volume here, gas. It's going to be your reactants, the benzene and the acetone. It's not going to be the air. This stuff is going to come up and push half of the air out of there. And when I say half, I'm just guessing. It's a nice, easy number. So I divide this by 2. Because if this much gas is in the, can be in 1 liter, and half of them are air, we want to know about the air. So if this is how much air you would have, right? If half of this is this, right? Because the other half is going to be your benzene or whatever you're refluxing. So now, remember we said 80% of the, whatever, a lot of the air is nitrogen, right? Or argon or whatever, that's not even reacting. So we're going to say 20% of this is bad. So we take it down here times 0.2, 20%, and we get 0.00444643 moles of bad stuff that's going to be in that empty volume of space where you're refluxing. 0.004, 4,000ths of a mole. That's like nothing. What's the point in even trying to get that out of there? Who cares if that's there? In my mind, that's nothing. 0.004 moles? Come on, man. So I'm gonna, if I ever do this experiment, I would do it with, with the inert atmosphere, but I would see what my yield was and then do the same exact thing and not use an inert atmosphere and see what the difference is. I can't imagine this little bit of oxygen or this little bit of contaminant that's in the vapor phase, and you know that the manganese acetate has to, do its work inside the liquid, not inside the vapor phase. Why would you even care about this oxygen? I don't know. But let's get into how you would do it if you wanted to use the argon, okay? All right, well, let's see what you do if you have a tank first. If you have a tank, you'd have to have a little nozzle here, an adapter, or else a 2-neck flask, so that you can put an adapter on so you can put hoses, okay? This would be your tank of argon, or whatever you get, nitrogen, whatever. Now, if you get it from, argon as argon, like, like a welding store or something like that, there's not going to be any water in it. It's going to be nice and pure. But you just connect the hose from the tank to this thingy here, because you want it to go in and up. You don't want it to go in on the top. You want it to go in on the bottom, right? So if you go into the top, you're going to be taking all your chemicals and sucking them out this way here. You know what I mean? You got to have an in and an out. So the in always has to be at the bottom. You would need a check valve and a pressure regulator valve. Okay. Now pressure regulator valves, they're rated by a couple things. I think 2 different things. But one of them is liters per minute. Okay. And I'm just guessing, because the truth is I don't know how to do any of this. Okay. So remember that when you're watching this video. I've never done this. No one's told me how to do it. I haven't watched videos on it. I'm just guessing, okay? I would guess you would want 0.016 liters per minute. That's a liter per hour. You're refluxing for 90 minutes. So within the first hour, you would fill up that empty space. Because remember, you only got a liter of empty space, right? You would fill that up within that hour, and then the next half hour you'd fill up another half a liter, okay? I don't know how they're rated or what they're rated at. You'd have to look into that. Going over some stuff here that I'm guessing at, basically. That's what I would try to rate it at if I could, okay? You'd have to flush the system. By the system, I mean the apparatus. So you have this all connected up. You'd have to pour in some argon, not at this, liter per hour thing, because that'd take forever. You'd have to leave it in there and flush all the air out. If you're going in from the top, it'll push all the air out, and then all you'll have in there is argon, right? Now at that point, now you set your pressure regulator at 0.061 or 0.016, and it'll, little by little, that way it doesn't carry all your stuff away, because if it comes in here and is leaving at the top, it's going to carry your vapors away with it. You know what I mean? Of course, so you're going to have to extend your condenser more, right? You want a longer condenser so it has more chance to condense the stuff out and not take your chemicals away, right? You don't need a drying tube, because that will just impede stuff. The drying tube is so that no water can get into your apparatus. Well, you don't have any water. All you have is argon. So you don't have to have a drying tube. And basically you would just start your refluxing, right? And you have the thing coming at 0.016 liter per minute, and that way it'll keep all the air out and you'll have an inert atmosphere, okay? Now, these cans that you get from eBay or whatever I said, they might have water in it because they're used for wine, and who cares if there's a little water in it. But I doubt there is. I forgot to look up the MSDS, but you can always Google it, type in MSDS and Google the product, and it will tell you. But now how do you use this since it doesn't have the same whatever? You can always go get a car hose clamp. You know, if you don't know what I'm talking about, it's basically a piece of metal like that, and it has little holes in it like I drew. And you fold it up into a circle and it looks like that. And then there's a screw. You put your hose onto the, wherever, and then you have this. You put it in there, right? And this screw, as you screw it, it grips onto these holes here. And it makes the clamp smaller and smaller. And you'll squeeze the hose onto the whatever. You have to use one of those and then get it connected up to the check valve and the pressure regulator and basically do it the same exact way. The only difference is you'd have to have your adapter here using a car hose clamp. And then once you got it over to this, it'd be all the same thing. Then you have your check valve, your pressure regulator valve, etc., etc. Again, even with this method, you have to flush the system out first. You know what I mean? Flush all the air out and make sure that it's, all argon. Then set it at the 0.16 liters per minute. Okay, now that's the most proper way I can think of. Keep in mind, I don't know the exact methods or whatever. This is my most proper guess, okay? But if you wanted to do it, like a generic way, every 5 minutes, just flush the system out, right? There'll probably be a valve on the can, right? So you have those connected up, and at the beginning, you open up the can and flush it out for, a couple seconds or whatever, and then turn off the can. Put your drying tube back on there and just do the reaction. Every 5 minutes or so, just open your can up a little bit just to get the air out that would have came in by that time. You know what I mean? Every 5 minutes, go shh, give it a couple squirts of argon, Having the drying tube isn't a plug, but it does slow down diffusion, like from the air coming in and the argon coming out. And also, argon is heavy, so it's not going to want to come out as much as you would, if it was just regular air. You might be able to get away with just filling, flush it, fill it up once, and put your tube on, and your tube would help slow down diffusion. You're only going to reflux for 90 minutes, so. Or the third method I'm thinking of is put a balloon up on top to here, put a balloon up there and fasten it or tape it or whatever, and flush your system out first, put the balloon on, then put more argon in there until the balloon slightly fills up. Not a lot of pressure, but slightly fills up. And then just close this off. You'll be using a closed system, but the system is only closed by this balloon. You know what I mean? So if you build up too much pressure, the balloon will just get bigger. If you, have too low of pressure, the balloon will just get, smaller. And the pressure shouldn't be changing that much because you're always going to have the same amount of vapor. You know what I mean? It's not like you're heating this up and you're building up pressure, because the pressure builds up only in the flask. Once it comes up here, it starts to condense, and the pressure stays the same, between both of them. So you should be able to use just a balloon, and that way you don't have to keep flushing it over and over and over again. Each time you do that, you're going to lose some of your stuff probably out the condenser. You can just flush it out, put your balloon on, put some more argon in there, close it up, and start your reaction. You watch it carefully to make sure you're not building up too much pressure and getting leaks, you know what I mean? Anyways, you all have a great day, and always remember, science is great.